Hello everyone. On this video we will be looking at the chain rule for trigonometric functions. Alright, so before we get started on that, just a quick reminder. If you remember, the derivative of sine of x is equal to cosine of x. The derivative cosine of x is equal to negative sine of x. The derivative of tangent x is equal to secant squared of x. And I'll put the other three right next to it. The derivative of cosecant x is equal to negative cosecant tangent, or cotangent, sorry about that. The derivative of secant x is equal to secant x tangent x. And the derivative of cotangent x is equal to negative cosecant squared x. Alright. Now we're going to look at what the derivative would be if that x were to be a function. So if you had sine of 3x squared plus 4x plus 7 or something like that. So this is what it would look like. Okay, so the derivative, let's say sine, and if it was more than just x, let's say you had a whole function of x in there, then that would just equal cosine of that function of x times the derivative of that function of x. Okay, and it's the same thing with cosine. The derivative of cosine of that function of x would be equal negative sine of that function of x times the derivative of that function of x. Okay, same thing with tangent. The derivative of tangent of that function of x will equal secant squared of that function of x times the derivative of that function of x. Okay, so hopefully you're starting to see the connection between just the derivative of x, of a trig function of just x, and the derivative when you have an actual function instead of just the x value. Okay, for the most part, you're just getting the derivative and then multiplying it by the derivative of what's inside. Okay, so if you have the derivative of cosecant of a function of x, then that's going to equal negative cosecant times the function of x, cotangent times the function of x, or of the function of x, times the derivative of that function of x. Alright, so if we had secant, so the derivative of secant of that function of x is going to equal secant of that function of x times tangent times that function of x times the derivative of that function of x. Okay, and same thing with cotangent. You have the derivative of cotangent of a function of x, then that's going to equal negative cosecant squared of a function of x times the derivative of that function. All right, so if you are still writing, feel free to press pause, but we're going to go ahead and do a quick example. Okay, so let's say, for example, when f of x is equal to cosine of 3x squared, find f prime of x. All right. Okay, so now what's the one thing we know to be fact for now is that we know the derivative of cosine of x is equal to negative sine x. Okay, so that's one thing we know. But that's not just an x in there. You have a whole different function other than just x by itself. Okay, so that's when you use the chain rule. Okay, and we also know that the derivative, clean up that C a little bit, of cosine of a function of x is equal to negative sine of that function of x times the derivative of that function of x. All right. So to go ahead and answer our question here, I'm just going to rewrite that. F of x equals cosine of 3x squared. Okay, so that means the derivative of that will equal, what's the derivative of cosine is negative sine. So that's going to equal negative sine of that 3x squared times the derivative of 3x squared. All right. So that means our derivative will be negative sine 3x squared times the derivative of 3x squared will give us 6x. Okay, so we'll equal negative 6x sine of 3x squared. Okay, so as you can see, it's pretty similar to the regular chain rule where you find the derivative of the whole thing, then the derivative of what's inside. All right. So if you're still writing, feel free to press pause, but we're going to go ahead and go to our next example, which shows what to do if you're finding the composition of three functions. Composition of three functions. And I have no idea why I capitalized that T. There we go. Okay, so let's say if you have some k of x is equal to h of f of g of x. So you have a function inside a function inside another function. Okay, to find the derivative of that, so let's say we want to find k prime of x is going to equal h prime of f of g of x times f prime of g of x times g prime of x. Okay, so you take the derivative of the whole thing multiplied by the derivative of what's inside, and then you take the derivative of what's inside of that. Excuse me. All right, so let's go ahead and do a quick example. let's say we want to find the derivative of, let's say, k of x is equal to cosine fourth of 7x squared plus 1. Alright, so how exactly would we do that? Okay, first thing we do is rewrite it. Okay, so fourth cosine of 7x squared plus 1, you can just rewrite that as cosine of 7x squared plus 1 to the fourth power. Okay, so this is our k of x. Okay, so all we did was take that fourth power and put it on the outside. Okay, so if we look at our formula here, we see that k prime of x, okay, that's going to equal, remember, the derivative of the whole thing, so the derivative of this whole thing, so you have, bring down our 4, cosine of 7x squared plus 1, then we subtract 1, so that's to the third power, times the derivative of that whole thing, so that's the derivative of cosine of 7x squared plus 1 times the derivative of what's in there. Okay, so it's kind of just a layering of derivatives. You think of it that way. Okay, you do the whole thing, then you do what's inside, then you go even further to what's inside of there. Okay, so to go ahead and simplify these terms, you have 4 times cosine 7x squared plus 1 to the third power. Okay, so that's times the derivative of that whole thing, which is, remember, not inside, we're doing the inside here already, so that's just the derivative of this whole thing, which is negative sine of 7x squared plus 1 times the derivative of what's inside. So it's times 14x. Okay? Now, you're not going to do the chain rule here because it's already covered there. But it's just the separate chain rule for this one. Alright? So that's going to equal 4 times 14x. And we have that minus there, so we'll bring that minus out. So that's minus 56x times third cosine, so cosine to the third of 7x squared plus 1 times sine of 7x squared plus 1. Okay, so that is how you form a composition of 3 functions. Alright, so hopefully this made sense, and I will see you on the next video.